Hey everyone, in this video we're going to be talking about percents and percent change. First we're going to go over three percentage examples to better understand what percentages are, and then we're going to go on to two examples that deal with change in percentages. So first of all, a percent essentially is defined as being a part over the whole. And for the most part, you have control over what you consider to be the whole, although in a lot of cases there is a well-defined whole. But if I were to take a look at this rectangle here and I break it up into four even pieces, and if I were to shade in one of these bricks here, the shaded portion of this rectangle would be 1 compared to 4, or the part would be 1 and the whole would be 4 possible blocks. So we see that 1 over 4 is 0.25, or if you multiply the decimals by 100, you're going to obtain the percentage. In this case, if we shade in 1 block out of 4, the percent shaded is 25%. Or if we shade in 2 blocks out of 4, then this is going to equal 0.5, or as a percentage, multiplying this by 100, we would get 50%. And if we did a third block, so if we shade this one in here, we see that 3 of them are shaded out of 4, and that's 0.75, or 75% of the entire rectangle. And lastly, if we shade in the final piece here, that's 4 shaded blocks out of 4. So we see that the decimal here, 4 over 4, is just 1. And if we multiply this by 100, we would get 100%. Okay, so as a whole here, this rectangle was the whole, and it represents 100%. So that is percentages, right? A part over the whole. So let's see if we could apply this definition to a couple of problems. So I have 3 problems here. They're all fairly quick. We have the recommended daily allowance, or the RDA, for vitamin C is 60 milligrams. And in an orange, we have 47 milligrams of vitamin C. So what percent of the recommended daily allowance is provided by this serving? Now, working with this type of material, I think this is things that people come across very often. Look on the back of a nutrition label, you're going to see information like this, and it's helpful to be able to calculate percentages if you needed to. So again, let me go ahead and write that the percent is equal to the part over the whole, and we'll see if we can identify which is the part and which is the whole to see if we could get this percentage. So that's what we're being asked for too as well, right? So what percent of the recommended daily allowance is provided by this serving? So we see that we see that an orange contains 47 milligrams of vitamin C, right? And we know the recommended daily allowance is 60 milligrams. So this portion here would be considered the whole, and this 47 here is considered the part. Okay, because we want to compare our serving here to what's recommended to us, which is 60 milligrams. So the part would be 47 milligrams and divided by 60 milligrams. If you leave the units on here like this, we'll see that the units do in fact cancel. With percentages, there's not going to be any units on there. There shouldn't be. So the milligrams cancel, and we get 47 divided by 60. Okay, and you could go ahead and plug that into the calculator to see what you get. It comes out to be approximately 0.783, which if you multiply this by 100, we'll get the percentage 78.3%. Now, Another way to do this is using ratios. Notice at the very end here that we multiply by 100 to get the percentage. Okay, so we have to do a little conversion at the end. But if we know we want a percent, this is another way to do this. We could set up a ratio saying, okay, 47 divided by 60 is equal to X percent divided by 100. So when I write X over 100, I'm essentially writing, 47 over 60 is what percentage out of 100. So in order to solve this for X, we would see that first we would do 47 divided by 60, and we would get this number here, 0.783. And then if we multiply by 100 on both sides, let's see what we get here. We get 4,700 divided by 60. I know I had said you do 47 over 60 first, but if you do 4,700 divided by 60, we're going to get approximately 78.3. Okay, we don't get 0.783, but we immediately get 78.3, and this represents our percentage. Okay, so that's another way to find the percent. I suppose I'd want to write this off to the side. We'd get 78.3%. There we go. All right. So that's number one. We have a couple ways to think about it here. Either way is fine. Let's try that for number two as well. So for number two, we have a serving of cereal that provides 9% of the recommended daily allowance for sodium. So notice now we're given some different information. We're given a percentage here. Okay, now the recommended daily allowance for sodium is 2,500 milligrams. So how much sodium is in one serving of cereal? Well, again, I want to stress here that the percent is defined as being the part over the whole. Okay, so the 2,500 milligrams is the amount that's recommended. So that's the total amount. If you get 2,500 out of 2,500 milligrams, you have 100% of your RDA for sodium. So this portion here represents my whole, and this piece here is my percent. So now I'm looking for how much sodium is in one serving of cereal. So I'm looking for the part in this case. So if I have my equation like this, I could say, well, 0.09. Notice now how in this form here, this percent is written as a decimal. So if I use this equation, I have to convert the percent into a decimal first. So 0.09 is equal to, now the part, I'm going to call the part X, and then this is divided by the whole, which is 2,500. So essentially this is saying what number out of 2,500 is going to be 9%. Okay, so we need to figure out X here. So how would we do that? Well, since we're dividing by 2,500 here, we want to apply the inverse operation with the same number to get rid of it, which would be multiplication. So those cancel, and we do the same thing on the left side to keep the equation balanced. So we get 2,500 times 0.09. And you could go ahead and plug this into the calculator to do that type of calculation here. It looks like we should get 225. So 225 is equal to X. Now, what are the units on here? Well, we're dealing with milligrams, right? So 225 milligrams. Right? Now see if that makes sense too. You could go back and check your answer really easy. If you know you want 2,500 milligrams and you only have 225, well then what's 225 divided by 2,500? And you should see that you'll get 0.09 or 9%. Now I had mentioned a second way to do it up here by setting up a ratio. Okay, we have essentially what we have is a proportion, one ratio equal to another ratio. So now 9%, we're given 9%, right? That's 9 out of 100. So this is saying 9% is equal to, and then the proportion, the ratio here will be x over 2,500. Okay, and this is going to save us the work essentially of converting this percent to a decimal here. So 9 out of 100, that's the 0.09. Essentially we did that just by converting this straight into a decimal. But if you wanted to set up the ratio, this is how you could do it. So in order to solve for x here, we would go ahead and multiply both sides by 2,500, just like we did in the previous case. And one nice thing about multiplying by 2,500 here is we see that zeros have a nice tendency to cancel out like that. And this is only in certain cases when you're not separated by addition or subtraction, but in this case this works out fine. So what we have here is 25 times 9, and we could see that's going to be 225. So 9 times 20 is 180, and 9 times 5 is 45. So you sum those together and we get 225. So 225 is equal to x. And again, the units on here are milligrams. Okay, and for number 3, we have a similar situation. So we have 1 serving of orange juice contains 450 milligrams of potassium. So this is 1 serving, right? So this might be our part here, right? And they're telling us this is 13% of the recommended daily allowance. Okay, it's only 13%. So you're going to imagine, you're going to want a lot more potassium than this. So they want to know what the recommended daily allowance for potassium is. So if this is only 13%, we should imagine, maybe it's like 8 times more than this would be the recommended daily allowance, approximately. But let's go ahead and use our equation and see if we get something that makes sense here. So percent is, again, the part over the whole. So let's see if we could apply this now. So we're given a percentage. We're given 13%. So again, this particular equation has to be expressed as a decimal. Okay, unless you set this up as a ratio like we did over here, you're going to want to write this percent as 0.13. And now I know I had 450 milligrams. That's the part. And this is going to be divided by the whole. I'll just call that x. So in this case, they want to know the entire amount for the day that you should have. That's essentially going to be the whole. So part over the whole. So now this x value here is missing. So again, we need to solve for x. So what we do is we need to get this x out of the denominator. If you keep it in the denominator, it's disastrous to solve for. Eventually through the problem, you're going to need to get it out of the denominator. So we multiply both sides by x. So they cancel over here. And let me do parentheses here just to avoid any confusion with the multiplication dots here. So we have 0.13 times x is equal to 450. And now what's the final step? Well, we don't want 0.13x, we just want x. So we go ahead and divide by 0.13 on both sides. And we could go ahead and use a calculator for this example here. And if you do, it looks like we should obtain 3,000, approximately. So let me do the approximation here. X is approximately 3,462. And what are the units? Well, we're working with milligrams. So that should be milligrams. And that's what we would expect, right? If 450 is only 13%, then what's the whole going to be? Well, it's approximately 7 to 8 times more, close to 8 times this amount here, which it is. And you may want to go back and check your answer. If you do 450 divided by this number, we should see our decimal coming out to be about 0.13, or very close to it, since this is a little approximation. Okay, you may want to go ahead and try this one using ratios as well. You'd set this one up as 13 over 100 is equal to 450 over x. So I'll let you go ahead and try that one if you'd like to see if you could get this answer like that as well. So let's talk about, now that we did some percent examples, let's talk about percent change. So percent change is a little less intuitive than percentages. I think percentages we have a tendency to work with on almost a daily basis. A lot of people have a good understanding of percentages, but when it comes to percent change, it takes a little bit further thought in order to figure out what a question may be asking. So let's go ahead and talk about sales here. So if we have a coat and it normally costs $150, and it's on sale for $120, we may want to find the percent discount. Okay, or pretty much the percentage of money that you're saving for this item being on sale here. Okay, now in general, now you could have a percent change in two directions. Either you may have a discount or you may have a percentage growth, right? So it depends what you have, but if you want a formula, we could say that the percent change is going to equal, and this is a rough formula really here, so that'd be the change in value, and it depends what you're talking about. You don't have to be talking about money. Like in the second case here, we're talking about populations, but the same idea will apply. It's going to be the change in value, or some change in numbers that you're given over the original value. Okay, now this change in value, we would want to do absolute value here. Okay. And recall what the absolute value was. If this change in value is negative, we just take the positive version of that. All right, so this, you could use this as a rough formula for a percentage change. Okay. Now, the coat normally costs $150 and it's on sale for $120. So you may want to ask yourself, well, how much money did you save, right? And I think you could easily tell that you're going to save $30, right? Now, what is the percentage that you saved? Do you take that $30 and do you divide it by 120? Or do you take that $30 and divide it by 150? Well, let's think about this here. So if you put 30 over 120, you're going to obtain 25% discount, right? Now, if you do 25% of 150, you're not going to get $30. Okay. What would you get? Would you get 30, 35? No, a little bit more. This is not a nice number. 37 or something. But you're not going to get $30. So that's one way to tell that we're not going to divide it by the 120, because if you're saying you saved 25%, well, ask yourself, what's 25% of 150? And it's not $30. So that's one way to see that we're not going to divide by the 120. So if we follow this formula here, the change in value, so we start with $150. The change in value would be the subtraction of the two numbers, and again, it's $30. And we're going to divide this by the original value, which is 150. So this comes out to be 30 divided by 150, which is equal to 0.2, or 20%. Okay, so that's one way of finding the percent discount, is to find that change in value and divide it by the original value. Now, another way you could think about this is, let's see. So, all right, so this is one way. Now the other way, we could say, well, 120. Now if we divide this by 150, so you could take the new value and divide it by the original value, and we'll see that this is equal to 0.8, or 80%. Okay. Now, what we're saying here is 120 is 80% of my original value. So this is the part over the whole. And what you saved is going to be the difference between 100% and 80%. So 100% minus 80%, right? That's the starting price. And that's the new price, essentially, is 80%. So we see that the discount is 20%. So this is another way to find this 20% here. Okay, so let's apply this to the fifth example here. So in 1990, we have the population of Nevada was 1,202,000, and in 2000, the population was 1,998,000. So we see there's a population growth, right? Over that 10-year period, approximately 796,000 more people moved to Nevada. So we want to find the percent increase over this 10-year span. So if we follow the percent change idea up here, that it's going to be the change in value divided by the original value. If we follow this, so let's get this percent change will equal, now the change in value, it doesn't matter which way you do the subtraction because we're taking the absolute value, but what's the difference between these two numbers? Well, we have 1,998,000, and we're going to subtract 1,202,000, and then we're going to divide this by the original value. Okay, the same idea is going to hold here. We don't want to take the change in value and divide it by the new value. Okay, we want to divide it by the original value, and it just takes a little bit of work. I mean, if you're not sure which one it is, you may want to test both and check your answer against the reality of the situation here, like we did in this money problem here. So we want to divide it by the original value, which is 1,202,000. Okay. And we're going to get, so this number minus this number is 796,000. And we're dividing this by 1,202,000. Okay, and so this looks like it comes out to be, let me do the approximation again. So approximately 0.66 or 66%. Okay, so that's one way of finding it. Or, like in the case of the sale here, we did this new value divided by the original value, right? And then let's see what we get for that and see if we could come to our answer. So if we do the new value, by the way, this is the answer. So the population grew by 66%. One way to check this is if you do 66% of your original population, and then you add it to the original population, we should obtain this 1,998,000. So a different way to do it is you could take this 1,998,000 divided by the original amount, and we see that this is approximately going to be 1.66. Okay, and this is equal to 166%. So the percent increase is going to be the percentage over 100%, because, suppose we had the same population over that 10-year span. Suppose the population started at 1,202,000, and in 10 years it was the same thing, still 1,202,000. Then that's 100% of the original value, right? So we didn't see any growth in that case. But in this case, we see that the new population is 166% of the original population. So the amount over 100% will be the population growth. So we want to subtract 100% and we get 66%. So that's another way to see that particular answer here. Okay, so either way you think about these problems, we should be getting these answers here. So I encourage you to go back and try a few more of these examples. If you didn't understand, you could click back here and take a look at 1, 2, and 3, or you could go over these problems again and think about these any way that is best for you. So I hope you enjoyed this video, and I'll see you in the next one.